3 and 4 are lesson 3, graphing inequalities. So first of all, we have to know what inequalities are. They are used in place of an equal sign. Okay? So an equal sign means it's like a balance beam, where the left-hand side of the equation is identically equal to the left-hand side. Okay? They weigh the same. On here, what does this first arrow mean? What do you think that one means? Well, it's one or the other, right? Less than or greater than? It's actually greater than. Okay? So write that one down, please. It's greater than. That one is greater than. Okay, what do we think the second one means? Greater than or equal to. Okay, greater than or equal to. And then we got the one pointing left. It's the less than, the one that points left. I'm going to give you a hint on how to remember these in a moment. And the bottom one, what does it mean? Less than or equal to. Okay, so less than or equal to. Now we're going to actually start graphing these on our grids, okay? We're going to start graphing these on paper. So we need to know what they are. When we solve for variables, variables are along the x-axis, we say. So that means we're going to have arrows that point either left or they're going to point right. Okay, that's what we're going to have. So you see here on the bottom, we've got arrows pointing left or right. A couple of them have black dots and a couple of them have white dots. There's a difference on what they mean. If they've got a black dot, it means they have the line underneath the inequality sign, which means the answer can be that number. It can be equal to it. So these ones are less than equal to, greater than equal to. Okay, that's what that one means. Okay, the ones with the white dots mean. What would the white dots be talking about? These guys have the lines underneath them. What do these guys have? No lines, right? So the one pointing left will be less than, the one pointing right will be greater than. Okay, that's what they talk about. Okay, and we will learn what that means in a moment. So I do an example here. So, the way to remember less than and greater than. Try not to think of what's eating what, or sometimes people think of the alligator eating something bigger. The easiest way to remember it is the way they point is what they're telling you about. So the ones that point this way, they're pointing towards the left like an arrow, correct? Well, if you opened up your fingers in your hand could make an L like that, correct? So that's like left. So if it points left, it's going to be less than. Okay, so if it points left, it's less than. Good to go? And if it points right, it's greater than. Good. Well, the only difference is if it's got that line underneath. Now, the line underneath means the answer can be that. Or it could be going the other way. So let's take a look at this example here. Here's my first example. So it's telling me B is less than or equal to 4. Okay, how do I know it's less than? Because this guy looks like a L that's been kicked over, right? It's an L that's been kicked over on the side. So that's a less than sign. So it says my number 4 is less than, okay, and B is less than 4. So what we're going to do is, in order to draw this guy, we have to think. This sign here tells us the color of the dot. What color of dot am I going to use, black or white? I'm going to use a black one. I'm going to fill it in. So I'm just going to draw a black dot right on my line. Okay, it's the first thing you do. So that's a number line. We're going to draw a black dot. And now we're going to point an arrow on top of it, pointing the direction of the inequality sign. So this guy points left, so is the arrow on top of that dot. It's going to point left. Okay? Then we put the answer to the variable underneath. So the 4 goes underneath the dots. Okay? Now this graph, it's a number line. So number lines always have arrows at the ends of them. A lot of times they don't show them that. Some of the computer programs don't put arrows on them. But please understand that there's arrows there. And then they will extend infinitely in both directions, right? Because we know that number lines deal with all the rational numbers. Correct? So we can get run-on decimals. We can go from positive and negative infinity. Okay? That's back from Unit 2. So this is the way we graph B is less than or equal to negative or to positive 4. we can only solve these and graph them this way if the variable is on the left-hand side. If the variable's on the right, we have to do something else. But in order to graph these, we can only graph them if the variable's on the left. So the first thing we have to do, though, is check. Variable on the left? Yes. Then you can graph it. Okay? Those steps are coming up right away. So it says, in order to graph, here we go. An inequality. The variable must be on which side did I just say? The left. Good job. So it must be on the left side of the equation. If the variable's on the wrong side, the terms on both sides can switch places, just like we do when we have an equal sign. We can switch them places, but there's one extra thing we have to do. When we switch them places, the inequality sign switches directions. Okay? So if it was pointing right to start with, it would point left. Okay? So that's the difference. Okay, now we're going to talk about how do we graph it. Okay, well we graph it with the arrow pointing the same direction. Okay, so the arrow, like in the other example we just did, the arrow has to point in the same direction the inequality sign did. But again, it's as long as the variable's on the left. That's super important. So as long as the variable is on the left-hand side of the equation, this rule can happen. Okay. What you just wrote down and what it's talking about is, if you've got the variable on the left, you can graph it no problem. If the variable's not on the left to graph, that means you need to change everything places. So for the first one here, the y is not on the left-hand side. So that means I've got to switch these guys places. And that's okay, I can do that. So I would put y here and 3 here. Now if there was an equal sign, I would just put the equal sign back in. But there's no equal sign. So that means that this sign, I have to change it directions when I do that. Okay, so now it's going to point to the right. Okay, that's if you flip them places. That's what you have to do. You have to switch the sign as well. Is A proper? Yes, it is. Is this third one proper? No, it's not. So let's switch these guys around. Let's see over here, -4 over here. Which way is my arrow going to point? Towards the who? The -4. And I've got my line underneath it, because that's greater than or equal to now. Okay? Is the far one on the right, the number 4 there, is that one correct? No, it's not. We got to switch him around as well. So X first, 5 over here, and now we switch it around. It's going to push the point left. Bless you all. Okay, this guy we do not have to change. Like we said, this one's in the correct order. We don't touch him. He is fine. Now we want to graph them. So again, like we did before, we just draw ourselves a little generic number line. So we're going to make mini number lines for each of them. So here's my mini number line for this one. There's my mini number line for that one. Mini number line for that guy. Mini number line for that guy. You don't have to put any numbers on it except for the answer below the circle. Okay? So we're going to take a look. Which way is it pointing when my variable's on the left? Which way is my variable pointing, or my arrow pointing on the first one? It's pointing to the right. So, am I going to have a white circle, or am I going to have a black dark circle filled in? A white one, because there's no line underneath it. So this is going to be a white circle, and it's pointing to the right. So I'm going to point this to the right on top. Okay? And on the bottom I put the answer, 3. Simple as that. We're done. Okay? Let's go to the next one. Letter A. Am I going to have a black circle or a white circle? The first thing we look at is our inequality sign. That tells me black or white. Which one is it? It's black. Good. Let's draw a black circle or a filled-in shaded circle, whichever you like to call it. Okay? Now, which way is it pointing? It's pointing to the right. Good. So we're going to point to the right. And what number goes underneath? 7. Perfect. Okay? Think you got a handle on that? Perfect. You try the next 2. Okay, the last 2. We switch this guy around. We have C is greater than or equal to -4. we have a black circle on our imaginary little mini number line. And it's going to have to point, as you said, in the right direction. Okay, it points right, just like our sign does. Okay, because this guy up here, he tells us how to point the arrow. He points to the right. Now the number underneath it, this guy's here, he goes underneath. -4. Let's look at the last one. We have x less than 5. We have a white circle. It's white because this sign does not have a line under it. We're going to point it left. Okay, what number goes underneath? 5. Perfect. All right, check your work. Okay, the next question says, how do we know when we can graph? We need to know when we can actually graph the inequality. Well, there's a certain time. We have to check if it's simplified. It is simplified. What that means is that all of the variables are collected and added together on the left. And there's only a hidden positive one in front of our variable. So you've reduced it, you have simplified it, and now all you have left is a hidden 1 in front of the variable. That's when you're ready to graph it. You cannot graph it if there's a number in front of your variable. Okay, that's super important. All right, so we check these two conditions. First one, is it simplified? Last one, is the variable on the left? If it's yes to both, then you're ready to graph. Now, if you say no to one of those, then you need to simplify it further. Okay? All right, let's take a look at the example on the bottom here. Again, we've got a b and a less than and equal to 4. So, this guy is going to be what color circle, black or white? Black circle, good. And what number goes on the bottom? 4. What number, where's the arrow pointing, left or right? Left, good. Okay, simple as that. Don't forget your little arrows on the end of your number line. It should always be infinite, right? Let's take a look at a couple of these examples. We'll see what they have to do. We want to be able to write now the equation from a graph. How would you write an equation from a graph if I gave you this instead? So if I give you this graph right here, here's my number line. If I give you a white circle pointing to the right and a -3 underneath, what would you draw? What would you draw for an equation? X, point to the right, and a -3. Do I need a line underneath my arrow? No, it's just greater than. Perfect. So what you've noticed is you put a variable here. Okay, variable goes first. Then you've got your inequality sign. That goes next. And it's the arrow that tells you which one it is. Okay, this arrow is telling me it's white, so there's no line underneath here. And the arrow up top is pointing to the right, so my inequality points to the right. Okay, simple little things you have to match up. Then the answer goes to the right-hand side of the equation. Okay, that's how we would work backwards. Okay, over here on top, we had to draw the graph from the equation. Now we're working backwards. Let's take a look at a couple more examples.
That number can be anywhere, I don't know.
It can be anywhere, absolutely. So let's take a look here. We have a -2. What kind of dot does a -2 have on this graph? It's a solid dot, right? If it's a solid black filled-in dot, what do? Okay, I point right with a line. Why is it pointing right? Because this guy's pointing right. Okay, that's the graph of my arrow. All right, that's why he's pointing to the right. So it's greater than or equal to. Where does my variable go? On the left. Somebody pick me a variable. Oh, you love X, eh? Okay, we'll use that. All right, on the right-hand side, what goes on the right-hand side? -2, beautiful. You guys tried B and C. All right. The inequality for letter B. Who's got that one? Okay, black in the back.
X.
Whoops. X.
On the left, 40
Left, so less than.
Yeah, 4.
Perfect. Excellent. Check your work, everybody. That's wonderful. That's exactly right. Letter C. Who's got letter C? Who's got that one cased? All right, sure. Stripes.
X, right,
And a line. Good. That's great. Better equal to. Wonderful. 10.5. Excellent. Check your work, everybody. Those are 100% right. Okay, working backwards. We had a chance to work on these ones. You already had a chance to draw those. Let's see what you came up with. Okay, who has A figured out? What is A? Green in the back.
it is -5 arrow pointing to the right.
Like that?
Well, oh, no.
Something's
There's a
missing.
circle, yeah.
Okay, what goes where?
This circle goes in the middle. And it's
Okay, what kind of
filled in.
circle?
It's not filled in.
Okay,
Arrow pointing right with the -5.
perfect. That's awesome. Okay, describe it properly. Okay, letter B, B, B. Who's got B? All right, gray in the middle.
There's a black dot,
Okay.
and then it's pointing to the right.
Ooh, you might think
Or
so.
to the left, I guess.
All right, let's back that one up for a moment. What do we notice first? Remember, we have to check two things before we start.
Oh.
Black.
X is on the right.
The X to the right is in the wrong spot, isn't it? We have to switch those guys' places first before we can even start. So we're going to put X first, the -2 over here. When we do that, what happens to our sign? It switches, so it's going to point left. Okay, it's still going to be a filled-in dot. Okay, it's still going to be a shaded filled-in dot, but now it's going to point left instead. But the -2 still goes underneath. Okay, so let's say you did a question like this on a quiz or on a unit assignment or a test. If you had everything right, the color of the dot was correct, the number underneath was correct, but you pointed the arrow wrong, you would only lose half of a point. Okay? All right. Take a look at C. Can we start when we see C, just the way it is?
No.
No, we can't. I'm glad you noticed that right away. What do I have to do to C? Sure, okay, we'll just go with that first. So we're going to switch those right away. So we're going to have A, and then I have a 0.5 over here. Now what happens? I have an A and a 0.5. Green.
Flip the middle sign.
Flip the middle sign. Perfect. All right. Somebody on the right here, tell me how I'm going to draw that. How would I draw that? Sure.
Black dot.
Black dot. Perfect.
Arrow
Arrow to the right. 0.5 underneath. Beautiful. All right. Can we do D? Is D able to graph right away without switching nothing?
Yes.
You bet it is. Okay, what color dot am I going to have? In the back. Just a circle, not filled in. Perfect. What else? Pointing left. Yeah, just keep it as a fraction. You bet. Yeah. Good. -25 over 3. It's just a fraction. You don't have to turn to a decimal. Just leave it as a fraction. You got all of those right.
Yeah.
You're flying through it. Wonderful. Okay, that is the end of 4.3. Now we're going to hit 4.4. Here we go. Stay tuned. Yes. We're going to do all of these things now, but now we've got something in front of X, and we've got something else beside X. Okay, so we've got to learn how to deal with those. But the trick is we already know how to deal with these questions. All we do is we solve them the way we did in the first couple lessons. We pretend there's an equal sign in there, and we solve it normally. And at the very last step is where we go back and we put that inequality sign in. Okay? Let's take a look at what this is telling us. So it says you use the same rules when solving normal equations. Aha! Absolutely. Instead of using the equal sign, you now use the signs that show us the inequalities. Okay? The less than or equal to, greater than or equal to. Those are the ones that are going to be instead of the equal sign. You won't see both. Okay? Now it says, remember, whatever you do to one side of the equation, you must do the other side of the equation, okay? Definitely, you must do it to the other side. If you don't, you put your equation unbalanced. And these are inequalities now, okay? So if they're inequalities, we've got multiple types of solutions we can have. So let's take a look at what that would look like for us. If I have this, I want to talk about different numbers of solutions. Let's take a look at this one first. If I've got y is less than 7, I have y is less than 7. Okay, I'm going to draw my mini number line. I'm going to put a circle. What color? It's going to be white, not filled in. What's underneath it? 7, perfect. And which way does it point? Left, okay. Now you're going to often be asked, what is a solution? What's a possible solution for that? Or they're going to say, are these numbers possible solutions for this? What they're saying is, any answer that is to the left on the number line of this guy, anything over here on the number line is a possible answer. But everything on the right-hand side of that line, or of the dot, is not an answer. So if I said to you, is negative 52 an answer?
Yes.
What would you tell me? Yes, it is. You betcha. Because it's way the heck over here on the number line. Okay? Is positive 52 a possible answer? No. Positive 52 is not a possible answer because it's way over here on the positive side. And we've always got to stay in the range that the arrow points us. So we can only go in that direction the way the arrow points. What other numbers would be possible solutions? Hands up. What other numbers could be possible solutions? 5. Excellent. 6. Yes. 0. Nice. How about, give me a couple decimal answers.
Negative 12 million point 5.
Okay, negative 12 million point 5. Yes, it's a possible answer. Any others? 1.632. What about 6.99? Is that a possible answer? Yes, because 6.99 would be about right there. What about 7? Is 7 a possible answer to that one? No, it's not. Good. Because it's a white circle. So 7's not a possible answer for this question. Okay, so does that make sense on this? On how to figure that out? Because you're often going to be asked that. Are these possible solutions? Well, the only way to honestly figure it out is to draw yourself a graph and visually look at that number line and see where those numbers are on the line. And if they are going in the same direction in the side with your arrow, they're all possible solutions, infinitely to that direction. Okay? Billions and zillions of them. Okay, let's find some examples here now. Last time we were solving equations, we solved with boxes, we solved with balance beams, we solved with inverse operations. We already know how to do all that stuff. We're going to keep doing all that stuff. The only thing that's different now is we have one of those in the middle. Okay? It doesn't change much. All we're going to do is we're going to pretend it's not there. We're going to pretend it's an equal sign for now, and we're going to solve it normally. And then our very last step, we're going to put the inequality sign back in. Okay? So, I'm going to start solving. Yes, sir. Okay, very good question. We're going to find out any answer. The arrow is pointing to the right. So yes, any answer that is bigger than my 3.4 can be definitely an answer. I also have something over here by my x, so I have to move him over. Because what we're actually finding, even though there's multiple solutions, we're finding what the minimum value or maximum value of those solutions can be. Okay, we're finding the boundary of the solution. So let's take a look. We're back to our normal operations. So if I rewrote this, I would have x plus 5.3 equals 3.4. We know how to solve those questions, correct? Absolutely. I'll give you a couple minutes. Solve that one, please. Okay. Did you get a chance to solve that one? All right. It's only a one-stepper. We need to take this guy to the right. We subtract him. Or we can use our boxes. We're going to get x equals negative 1.9. This is the step where we go back and we say, okay, well, we didn't have an equal sign to begin with. We had an inequality sign. So now we go back and we put the inequality sign that we started with back in. Okay, there's our inequality sign. Now we can draw the graph that matches it. So if I have my mini number line here, what kind of circle am I going to have? Is it going to be a solid or a white one?
White.
A white one, good. Which way does it point now? To the right, good. Does it matter that my answer here is a negative? No, it doesn't matter if it's a negative. It still points to the direction the arrow is. Okay, what number goes underneath? Negative 1.9. Perfect. All right, let's take a look at B. We have to do the same kind of thing with B. Okay, so it showed us our boundary. The smallest number that it cannot be is negative 1.9. So that means negative 1.8 repeating. Yes, that could be a possible solution. Okay, that's our lowest boundary. Let's take a look at B. I have to do inverse operations. What is the opposite of subtracting 3? Adding 3. Good. So I'm going to add 3 to both sides. That makes my 0 pair on the left. So now it poof disappears. I have C less than or equal to 7. Can I draw that graph? Yes, I can. All right, let's draw that graph.
Can I just do the rest?
Okay, here we go. Here's our little mini number line. It's going to be a solid circle because we have that line underneath it. So you have to fill that circle in. It's pointing left, and 7's the boundary. So this question says 7. Yes, the answer can be 7, but it's got to be every other number below it as well. It cannot go higher than 7. Okay, that's what that's telling us. On letter C, we have a couple things going on now. We've got multiplying and dividing. We've got all kinds of stuff. So we're going to solve it normally. In order to solve this question, we've got to take our variable to the left. Okay, remember, you always want your variables collected on the left-hand side. So how do we take a positive, it's got a hidden positive sign, how do we take a positive 3y to the left and make it a 0 pair? You subtract it, good. So if I subtract 3y's, plus 3 subtract 3 gives me 0. It disappears. So now I'm going to put the subtract 3y's over here. Why did I write it underneath the 5? Because the 5 has the y, good. And so does the negative 3. You have to match them up. Alright, so now I'm going to rewrite the equation. These will disappear. I add those up. What's 5 subtract 3? 2. So I'm going to have 2y's, subtract 6, less than or equal to negative 12. Okay? Are we able to solve questions like that? Yes, we are. Okay? So I'll give you a couple minutes to solve that one. Okay, let's take a look at this guy. We've got top left-hand corner. Who goes first? The y does. Bottom right. Negative 12. Perfect. What's the first thing that happened to y? Times by 2 to give me a 2y. Then what happened to him? Subtracted 6. So I get 2y subtract 6 equals my negative 12. Now I have to work backwards. So subtracting 6, what am I going to do down here? I'm going to add 6. What's negative 12 plusing 6? Negative 6. Good job. Now up here we times by 2. What are we going to do at the bottom? We're going to divide by 2. Okay, what's negative 6 divided by 2? Negative 3. Perfect. So now remember, we always pull this off the boxes. We're going to solve it. So we're going to say, okay, y, and we have a negative 3. What sign goes in here? That sign goes in there. So less than or equal to. Now I have to graph it. So we're going to draw our mini number line. There's my mini number line. What kind of dots am I going to have? Is it going to be a shaded black one or a white one? Shaded. Good. All right. Which way is it pointing? To the left, to the left. Perfect. What number's underneath? Negative 3. Somebody give me a possible solution, please. What is a possible solution for that? Negative 17, yes. Negative 2? No, negative 2 is going to be way over here. So negative 2 is not a solution. Negative 3 is a solution, yes, because it's a shaded dot. Okay, which means that I can have that for a solution. If it was white, I couldn't have that for a solution. Okay, let's go to the next question. Give it a try on your own, and then we'll do it together. Okay, now some of you might have already found out, it's on the wrong side, so I've got to put this stuff, whoa, my goodness. I've got to put these guys, oopsie, not the D, but the 15 over here, right? Because it's kind of backwards. So I'm going to have to go negative 3y, subtract 3, and the 15 over here. Now when I do that, what happens to this side? It flips direction, so it's going to go right and with the line underneath it, okay? That's the first step, okay? Now we have to actually do the boxes. So if we do our boxes, we've got this. So I'm going to have y in the first box. What happened to y very first? It's what's sitting beside him. He times by negative 3. Okay, times by -3. Now when you're doing this box strategy, make sure you're drawing the operation of what's happening. A lot of you on the quizzes that I'm noticing in the formative assessments, you're actually just drawing the numbers up there. You're not writing whether or not you're adding, subtracting, multiplying, or dividing. And then that's going to mess things up when you come down on the bottom. All right, so now we've got 15 on the bottom right. We get -3y, we times by -3. Then what happened to y? Subtract 3. So we're going to get -3y, subtract 3. And then now we have to work backwards. What are we going to do? Add 3 to get 18. Now what? Divide by what kind of 3? -3. Okay, here's where it gets a bit tricky. So 18 divided by -3 is -6. So I should get this for an answer. Y, -6, and it looks like I'm going to do this, right? This is the trick. When your very last step, so right down here, this very last step, if you multiply or divide by a negative number, okay, your last step, if you multiply or divide by a negative number, this has to switch directions again.
Oh,
I know. Gets a bit tricky, doesn't it? Okay, so that's the way it looks to start and to end. Okay, so that step is kind of confusing. We still have to really remember all of this switching does take place if our last step is dividing or times by a negative. Okay, that's a big step we have to remember. Last question. It is a word problem, of course. It says, okay, our problem solving question says, Ben plans to board his dog. PP Kennel charges $90 plus $5 a day, and Whoop charges $100 plus $4 a day. How many days does Ben have to board his dog before PP Kennel costs less than Whoop? So we want PP less than Whoop, is what we're looking for. PP less than Whoop Kennels. So we have to figure it out. Well, let's let D equal the number of days. And let's figure out what it means. Okay, so we've got PP Kennel. What does that give us for an equation? Well, we've got a $90 base charge plus $5 per day. And the next one, we have Whoop Kennels. Now, Whoop Kennels, it tells us, is $100 plus $4 per day. So we need to set our equation up as PP being less than Whoop. So the PP part is going to go on the left of the equation, and the Whoop is going to go on the right. So we've got 90 plus 5 D's is less than, that's where our less than comes down, 100 plus 4 D's. Now we're back to normal equation solving. All we have to do is take our D to the left. So this guy's got to go to the left. You need to make them a zero pair. Subtract your 4D. That makes them 0 on this side. But remember, you need to do it to both sides. So minus 4D's. All right, next step, you write your equation. 90 plus, we add these together and get a positive 1D less than 100. Now we can solve it. You can solve it any way you like. Inverse operations, you're using your boxes. I'll use the boxes since you seem to like your boxes. So, oh, I just need 2 of them, pardon me. On the bottom. So we have a D. What happened to D? It was added 90. So we have D plus 90. 100 should be the answer. We added 90 up here on the bottom. We are going to do the opposite and subtract 90. So we get 10. So we have D, the inequality sign comes back, and we put our 10. Again, the one thing you want to check was the last step, multiplying or dividing by a negative. Here, no, it was not. All we did was we subtracted 90. So the solution stays the same. He must be there for less than 10 days for it to be cheaper. That's how it's a better deal. Less than 10 days. This concludes lesson 4.4 of inequalities.